Distillation is they are talking about to distill something, talking of liquids, two liquids of different boiling point, mixable liquid. You mix two liquids together. How will you separate them? Distill or distillation. It goes by a process. Now, distillation, is a separation. We know distillation as a physical separation process used to separate substances in a mixture based on differences in their boiling point. So distillation goes, so if you heat the substance, it boils up, it changes from liquid to gas, and based on different boiling points, the substances get separated. Now you see the diagram here. This is a round bottom flask. This is a heat, and we are looking at two substances. Example of this will involve ethanol. The common one is of ethanol, that's alcohol and water. Alcohol and water, if you burn it, if you boil it, water boils at 100 degrees and ethanol boils at 78 degrees. So the first degrees and the ethanol begin to vaporize. When it vaporize, boom, it will be collected here, and before it is 100 degrees, you are afraid there is already separation. So we have heating, vaporization, cooling, and condensation process. So this what happens, the water boils. When it boils, it comes here, it cools out. The temperature here will give you the temperature of the boiling point. Then when it comes here, pass the condenser, pass the condenser, and we get collected here. Now, so these are examples. The mixture of water and ethanol can be separated by distillation because ethanol and water have different boiling points. Ethanol is 78 degrees and water is 100 degrees. So as they vaporizes, this what happen. One of them, the ethanol vaporizes quick before the water, and boom, we call it crystalline. We call it fractional distillation or distillation. This is which is how we call distillation process. Now let's look at the diagram. How does it work? As explained, liquid A here has a lower boiling point, liquid B has a higher boiling point. So two liquids, but the boils are different boiling point. One is lower, one is higher. For water started boiling, let's say the boiling from 20, 30, 40, 50, 60, 70. Before it hits 70 to 80, one of the liquid will hit its boiling point, so it vaporizes. This what happens, liquid of lower boiling point vaporizes more easily, vapor directly condenses, and this is what's formed quickly, the diagram representation, and this is what we will need to know about vaporization. I want us to watch a short video to explain this concept. We are going to watch a short video to explain this into details. Thank you so much.
This is a distillation column.
What does it do?
It separates liquids based on their different boiling points.
Okay, let's explain what is called fractional distillation. Fractional distillation is a physical separation process used to separate a mixture of a liquid or hydrocarbons. Mixture of liquid or hydrocarbon that have different but relatively close boiling point. The boiling points are different. For example, the boiling point can be 70, 75, 74, 78, to that manner. So the difference in boiling point take care of the type of liquid that are formed. Now let's look at this. It is called fractional distillation because the mixture is separated into different fractions, different segments, different group, different substances, different area. We can so many synonyms for it. So fractions just means they are different components. So with each fraction containing substances that have similar boiling point or ranges. Now this is how it works. From heating, vaporization, repeated condensation, and vaporization and separation occurs. So let's look at this diagram, how it's happening here. This is the process. Look at the diagram. Look at this diagram. Amazing. This is a fractional distillation. Fractional distillation is a physical separation process. Now, the object is being changed. So if it's not a chemical, it's a physical change. It separates a mixture of liquid based on mainly on differences in boiling point. As we said, one substances have so many liquids in it. The technique used is, luckily, these substances or these liquids, they boil at different temperatures. So when they reach a temperature, it changes into gas. So when it changes into that gas, it condenses and it can be collected here, as you can see. So this is a crude oil. This is where the various, we have diesel, we have kerosene, we have gasoline, we have naphtha, we have LPG. This is various, they have various components, various differences in the boiling point. So the crude oil is heated so that many hydrocarbons vaporizes. The vapor enter a fractional column with difference in temperature gradient, different hydrocarbon condenses form different levels. So no new substances is for no, because it's only one substance which we use and it has different boiling points. So it's bring out all the substances in it. Let's look at what we mean by physical change. Now, why is a fractional distillation physical change? Why? You know, we have chemical change and physical change in chemistry. Now, why is there physical change? Now, is there new substances are formed? No. The same object, the same crude oil bend to produce different components of liquids and gases. So the same substance is a physical separation. So fractional distillation is a physical change because it separates substances without changing their chemical identities, chemical formation. They have the same, they are all hydrocarbons. The identity is the same. So crude oil is a mixture of many hydrocarbons. During a fractional distillation, these hydrocarbons are separated according to their differences boiling point. So the whole of this liquid are all hydrocarbons. That's making it a physical change. No new substances are formed. Now let's look at the setup, how this happened. Now in a nutshell, this is what happened. This is a crude oil. This is a crude oil. This is a sample. The crude will be dumped here and the serious burning take place here. And this is where, as it burns, it's heated, it vaporizes, condenses, and form various type of this lubrication oil, fuel here, diesel, paraffin, naphthalene, gasoline, LPG gas. All these things come from only one crude oil. That is why I call it what? It is a physical change. It is a fractional distillation. So hydrocarbons are compound primarily made of carbons and hydrogen. We know it already. So CH, crude oil contain molecules with different chain length, structure, boiling point. We shall look at it in my next video, how these hydrocarbons are formed in terms of a hydrocarbons formation. Important hydrocarbon groups include alkanes, cycloalkanes, aromatic hydrocarbons. We shall look at it later. Because components have different boiling point, the crude oil are separated with experience for that.
After petrol, we move further down the column to the kerosene fraction, where moderately heavier hydrocarbons condense.
Kerosene hydrocarbons have higher boiling points than petrol, so they condense at a lower and warmer region of the fractionating column.
Kerosene is a mixture of hydrocarbons in the middle distillate range. It is heavier than petrol, but lighter than diesel and fuel oil. As the vapors rise, temperature decreases. Kerosene condenses within its characteristic boiling range, allowing it to be separated from lighter and heavier fractions.
Kerosene has important applications as aviation turbine fuel and is also used for heating and certain cooking applications.
Kerosene is therefore collected below petrol because its hydrocarbons have higher boiling ranges. Next, we move further down the column to the diesel fraction.
Crude oil enters the distillation column and is heated from below. As it vaporizes, different hydrocarbons separate by their boiling points. Lighter products rise higher, while heavier fractions stay lower, producing LPG, gasoline, kerosene, diesel, and bitumen.
Crude oil looks like one liquid, but it's actually a mixture. Fractional distillation separates it, useful fractions by their different boiling points.
Welcome to fractional distillation. Crude oil is heated at the bottom of the column, producing hydrocarbon vapors that rise through cooler temperature zones.
As the vapors rise, the column becomes cooler. Each hydrocarbon fraction condenses at a different height based on its boiling point. LPG is the lightest fraction. It contains mainly propane and butane, which have very low boiling points and condense near the top of the column.
LPG is widely used for cooking, heating homes, and industrial fuel because it burns cleanly and efficiently.
Petrol forms below LPG because its hydrocarbons have higher boiling points. They condense in a slightly warmer part of the column.
Petrol is an important transportation fuel used in cars, motorcycles, and small engines. Fractional distillation separates crude oil into useful products according to boiling point.